Okay, scientific notation is something that we need to go over now also, and this is extremely important because you are going to see scientific notation in any and all of your science classes, any chemistries or physical sciences or physics, anything like that, because scientific notation is used whenever we want to talk about really, really huge numbers or when we want to talk about really, really, really tiny numbers. Now, scientific notation is technically some number that's between 1 and 10, so larger than 1 but smaller than 10, times 10 to a power. So let's see how this works. Let's say that we want to take a number like 78,000 and we want to write that in scientific notation. Well, remember that according to the definition, it said that it was a number between 1 and 10 times 10 to some power. Okay, technically, normally, the decimal lies right here in 78,000. So let's think about where would I have to move this so that I had a number that was larger than 1 but smaller than 10. Well, if I were to put that decimal right in there between the 7 and the 8, 7.8 is a number that is larger than 1 but smaller than 10. Now, this 7.8 times 10 to some power. What we need to do now is figure out what our power would be, and that is directly related to the number of decimal points that you had to move. So let's see, 1, 2, 3, 4. 4 would be here. Now, 10 to the fourth means 10 times 10 times 10 times 10. So that is really, really a huge number. This is actually 10,000. So what we're saying here by saying 7.8 times 10 to the fourth is 7.8 times 10,000. This is what's going to help you whenever you need to decide whether you're multiplying by a power that is positive or a power that is negative. Our positive powers create very, very large numbers. Negative powers create very, very small numbers. So this is how we would write this in scientific notation. Okay, let's try another one for practice. Here we have this number that's in standard form, and we want to write it in scientific notation. So remember, again, it's going to be some number times 10 to a power. Well, this number, I can move my decimal point around so that my decimal is between the 1 and the 6. That would give me the number 1.67. Now that is larger than 1, but smaller than 10. Now, in order to make that happen, we have to move our decimal point 1, 2, 3, 4, 5, 6 places. 6 places. But if I multiply by 10 to the 6th, that's going to create a huge number. And I don't want that. I want this itty bitty tiny decimal. So we have to be multiplying by 10 to the negative 6 power. Now, another thing that you can think of, I say another thing you can think of, the reason that this works the way that it does is because our number system is a base 10 number system. So basically, just for an example, if you were going to multiply 3 times 10, then we know that's 30. Or if we multiplied 3 times 100, then that would be 300. So really, we're just moving decimal places because we have a base 10 number system. So remember, whenever we're changing these things into scientific notation, we need a number between 1 and 10 raised to the power, and the power is the same number of places that you move the decimal.